Good evening, students. Today we're going to look at comparing two variables. I am your instructor, Richard Kofi as well. This is my email. I am from the Ghana Communication Technology University. This is my outline. Understanding the one sample data's common use, data requirements, sample of the data to be used. I do not own the right to this data, but of course I can use it for demonstrative purposes. The SPSS procedure and then the interpretation. What then is a one sample t-test? Remember, it allows us to test whether a sample mean. Remember, sample is what significantly differs from a hypothesized value. A sample mean significantly differ from a hypothesized value. Of course, the mean of a normally distributed interval variable. Remember, we've met the word interval variable. It examines whether the mean of the population is statistically different from a known or hypothesized value. What other name does it have? It's a parametric test and is also known as what the single sample t-test. The variable used in this test is known as the test variable. So, in a one sample t-test, the test variable mean is compared against the test value. There is a value that is given to you. So we compare the mean of the test variable to it, which is known as the hypothesized value of the mean in the population. The test value may come from a literature review in the case of a one sample t-test, a trusted research organization, a legal requirement, or an industry. For example, a survey over the period can establish the fact that before you get to a junior high level, you must have attained a certain age. And this has proven over the period. Then it is what? It's established through literature. There are other ways of establishing, maybe by law. The law of Ghana says you can marry at the age of what? 18. So it means 18 years you can marry. So the law requires. Again, what are the common use? One sample t-test is used to test the statistical difference between the mean and a known or a hypothesized value of the mean of the population. It is also used to test what the statistical difference between a change score and 0. Or you can also use it to compare a single sample mean to a specific constant. For example, the average age of students in a particular class or can be maybe 24. So that is a standard. We compare the sample mean to that specific constant mean. Now, what are the data requirements? In order to conduct such a study, first thing you must do is the data must meet the following. The test variable should be continuous. The variable for which we are comparing should be what? Continue. The score on the test variable are independent. Remember the word independent. What does it mean? It means there is no relationship between scores on the test value. The violation of this assumption will yield an inaccurate p-value. Watch earlier videos if you want to understand what a p-value is. Again, the data set must be random. Remember the introductory, we talk about random sample, and it must be homogeneous, homogeneity of variance. Your quantitative method would have taught you what variance is. Homogeneity of variance. That is, the variance is approximately equal in both the sample and the population. Remember the word sample. Remember population. And there is no outlier. This is not the first time we're going to make this. So there are no outliers. Again, the data set is normally distributed of the sample and population, and not normal distribution, especially those that are tailored or heavily skewed, considerably reduce the power of the test. So a non-normal population will have a negative influence on your result. Among moderate or large sample, evaluation of normality may yield inaccurate p-value, which is very dangerous. So how do we start with the hypothesis? Remember, hypothesis can be stated in the null form or an alternative. So the null hypothesis says that in the case of a two-tailed test, the null hypothesis says that the mu is equal to the mu zero. That is, the population mean is equal to the proposed mean. Then the alternative is saying, now, no, it is not equal. Where the mu, remember, is the true population mean, and the mu zero is the proposed mean of the population. So this is a formula for those of you interested. In this class, we are not really interested in calculation. So I put the formula there, and you just take a look at it and try to understand. This is the sample mean, this is the population mean. They are all estimated. And then the S is a sample standard deviation. The S bar is the estimated standard error. Now, how do we run this in SPSS? To run a one sample t-test in SPSS, click on Analyze, Compare Mean One Sample t-test. What happens? The window opens where you can specify the variable to be tested. All of the variable in your data set appears in the list on the left hand side. Then you move it to the test variable area by selecting in the list and clicking on the arrow, which I will demonstrate very soon in SPSS. Now, about our data. Our data is taken from the CDC. And according to the CDC of the US, the mean height of an adult US age 20 or older is 66.5 inches. It is higher for male than for female. So in our data set, we have a sample of 435 college students from a single college. And then based on that, we are going to test to see if the mean height of the student in this college is statistically significant, different from the 66.5 given to us by the CDC using the one sample t-test. Remember, our now an alternative hypothesis as stated below. The mean height is 66 inches, is equal to 66. Then the alternative says it is not equal to. But before we do it, we analyze. In fact, we have to use the continuous variable height. We go to analyze descriptive statistics and then describe. So we go to analyze descriptive statistics and then we describe it. Then the height exhibit the range of this, should be there. We create a histogram. How do we do that? We go to graph, legacy, histogram, move the variable height to the variable box and click on OK. Then add a vertical reference line to the data. How do you do that? Double click on the plot to open the chart. Then click on option, then the x-axis reference line. In the property window, you can also enter a specific location on the x-axis for the vertical line, or you can choose to have the reference line at the mean or median of the data. Now, before the test, what do? We continue and click on apply to make sure that the line is added to the chart. When we add the two reference lines, one at the sample mean, what you notice is the solid black line, and the other at the 66.5 will be a dash red line. This will be demonstrated in the next video using SPSS. So from the histogram, you can see that the height is relatively symmetrical. It distributed about the mean, though there is a slightly longer tail. And then the reference line indicates that the sample mean is slightly higher than the hypothesized mean, but not by a huge amount. It's possible that our test result could come back significant. So, based on this, how do we demonstrate this? Quickly, I go to my SPSS. With my SPSS, first I would like to see the nature of the data. So I click on Analyze, Descriptive, then I go Statistics, then I look for Descriptive. I select my height, of course. Then I click on OK. Automatically, it gives me the sample size, the minimum, maximum, mean, and then the standard deviation. That said, I would want to see the graph because it's a continuous variable. The best graph to use is the histogram. So graph, legacy, you move to histogram. I'm interested in my height, so I've already selected the height. After it, I click on OK. I would love to see the reference line. So I double click inside the graph, go to my option, select my reference. I would want to put the reference at the mean. So select it at the mean. Beautiful. Okay. And I close this. I'm also interested in getting to know the actual reference given to me. So I go, this is the actual position, after which I click on close and I have two lines. That is how you go about it in SPSS. Let me go back to my slides to explain further. So these have been demonstrated. And again, I would love to set my reference line at 66.5. So same procedure. I will click inside option, reference line. I want to set it at 66.5. After setting it, you click on apply. Beautiful. So these are the three reference lines I have. One closer to the mean, one already set by the system, and then the hypothesized value, which is 66 point what? Point. Thank you. So let me go back to my slide. All these have been demonstrated. Now, how do I run the test statistics? To run the test statistics, I go to Analyze, and then based on my Analyze, I use Compare Mean. And this is what you see. Once you see this, you select the variable of interest. If it is my height, I select the height. And all these variables, all these things, the numbers A, B, C, D, what do they mean? A is a test variable. It's a variable whose mean will be compared to the hypothesized mean. The test value is the hypothesized population mean. The estimated effect, which is optional, if you check it, will print the effect size statistics, namely the cohort D for the test statistics. Now, the D is the option. By clicking on the option, what do you find? You get the confidence interval. And if there is any missing value, you would also have to either include or exclude it. Then you click on continue. Then you can set your confidence interval to 99, 95 based on your choice. And you click on OK. And this is what you get. This will be demonstrated very soon. How do we interpret this? First, this is a sample. This is the mean, standard deviation, and then the standard error. Again, we have a t-value, df, degree of freedom, a one sample p, which is telling you it is less than 0.001. The two sample is also less than 0.001. The mean difference. This mean difference is the difference between the hypothesized mean, which is 66.65, and then the mean height generated by the system, which is what? 68.0318. The difference is what gives you this. We have the lower confidence interval, a higher confidence interval. For confidence interval, please watch my earlier video. So the output, how do we interpret the output? It provides the basic information about the selected variable height. Remember, there are no missing. Remember again, our mean height, already explained it, is what 68.03 inches, which is based on what 408 non-missing observation. Whilst if you want to do a detailed interpretation, again, the one sample, the test value, right, which we enter, the t statistics, what does it say? The t statistics, it has a t value of what? 5.810. Note that t is calculated by dividing the mean difference by the standard error. df, the degree of freedom. For us is what? The df is the n, the sample minus 1. The confidence interval is a confidence interval for the difference between the specified test and the sample mean. The specified test value and the sample mean, the difference between the specified, remember our specified test value and our sample mean? Then we have we have the significance. The significance gives us a one-sided P and a two-sided P. The p-value corresponds to one of the possible one-sided alternatives. Remember, our hypothesized value is already given. The two-sided alternative says it is not equal, respectively. But most especially, the interest is in the two-sided alternative hypothesis. I repeat, the p-value corresponds to one of the possible one-sided alternative hypothesis. That is, the mean height is greater than 66.5. And the two-sided alternative hypothesis says it is not equal to 66.5. We are interested in the two-sided alternative hypothesis. What is the mean difference? I have said it. The difference between the observed mean and the expected mean. And this is specified. This is what the specified test value. Option A. Now the sign of the sign of the mean difference corresponds to the sign of the t value. The positive t value, remember, in this our example, indicates that the mean height of the sample is greater than the hypothesized height. Meaning, the height that we got from our study is higher than the height that the CDC said was the average height for those 20 years and above. So if the mean difference is positive, the t-value will be positive. If it is negative, the t-value will have a negative sign. Now, the most important, but before the most important, and least I forget, I promise running the analysis in SPSS. So how do we go about it? This is my data. I go to analyze, compare mean. What am I interested in? A one sample t-test. The variable of interest is the mean height. What is our test value? 66.5. Let's try the options. 95% confidence interval. I would love to continue. Based on this, I click on what? Okay, and voila, this is my results. Exactly the same as those presented in the lecture note. As those presented in the lecture note. Remember the confidence interval, the mean difference, the degree of freedom. Please do try it at home. Back to my lecture note. Most important, how do we interpret? So, to interpret, first tell us what the hypothesized population value is. Again, tell us what the average height that you got from the analysis is and give us a gist of the p-value. So I say, recall that our hypothesized population value is 66.5 inches, approximately the height of the overall adult population in the US. Since our p-value is less than 0.01, what do? We reject the null hypothesis. Remember, the null hypothesis is saying it is equal. The alternative is saying it is not equal. We found out that the p-value is significant. Remember, the yardstick for the p-value is 5%, that is 0.05. If it is greater than 0.05, we would not have rejected. But this is less than 0.05, the p-value. So we reject the null hypothesis that the mean height of the student at the college is equal to the hypothesized population mean of 66.5 inches. Based on that, ladies and gentlemen, we conclude that the mean height is significantly different than the 66.5 inches, meaning it is not true, and the mean height is what of those 20 years and above is what 66.5 inches. Again, we can say that based on our results, we can conclude there is a significant difference in the mean height of the students at the college and the overall adult population in the US because our p-value is 0.01. 0.001. Sorry, 0.001, which is what? Less than the yardstick of what? 0.05. Again, the average height of the student at the college is what? 1.5 inches taller than the average than the adult population. And this can also be seen from the 99% confidence interval. Note that the 1.5 lies between the lower boundary of the confidence interval and the upper boundary, implying it is statistically significant. Back to our results. Back to our results, ladies and gentlemen. The lower boundary is thus 1.5 is 1.0135 and the upper boundary is 2.051. The mean difference lies between them, so it is also statistically significant. Remember, you can look at it from the point of a p-value, or you can look at it from the point of the confidence interval. And the interpretation is very straightforward. One and the most important thing is for you to interpret the p-value. The mean difference, you must tell me, you must also interpret it. And it is always important to give the reader a gist of the data by telling us what the descriptives are. On a note, I would love to end the class here, and I hope you will enjoy the one sample t-test. If there is any takeaway, know the definition of a one sample t-test. What are the assumptions? What do we mean when we say a data is normally distributed or non-normally distributed? What is an outlier? How do we state the hypothesis? And how do we interpret the results? Please have a good evening. Let's meet next time in the next video to talk about the independent sample t-test. Bye-bye. See you next time.